So I will be talking about something different than CMSs or Drupal today. I will be talking about DOM, HTML5, and PHP. But before I actually do that, I'll introduce myself briefly. So I'm Niels. I studied computer science. And for my day job, I actually work in static analysis. So I actually don't do any web development or don't do any PHP for my day job. However, as a consequence of doing static analysis, I kind of became one of the people who maintain the PHP core. So I'm a core developer / core maintainer. And I've been doing that for like 2.5 years now. As part of the PHP work, I'm lead maintainer of the XML and the DOM extensions. And besides that, I also generally work on bug fixes and performance improvements in PHP. There are a couple of things in the title of my presentation that I must explain, like what on earth is DOM? And DOM is just like an extension built into PHP to take some HTML, take some XML, and create like an object-oriented representation on it, on which you can do various operations. And these operations may look familiar to you. In fact, these are the same operations that you can do on documents in JavaScript. And people use this in PHP to do all sorts of stuff, like validation or sanitization of the HTML. People use this for APIs, for example. That's more for the XML stuff. Yes, XML APIs still exist. People use this for scraping, so like the counterpart of Beautiful Soup for Python, you can use a DOM extension for this. And also people use this in template engines. And there's also more niche applications that I won't go into today. HTML5, there's a lot of confusion actually about what HTML5 actually means, because there's like different versions of HTML5, but not actually. You also have something called the Leuven standard. And there's also like this weird relation between W3C and the WHAT working group. If you don't know what the WHAT working group is, that's the working group that nowadays develops the HTML standard. It stands for the Web Hypertext Application Technology Working Group, and it consists of browser vendors, basically. If you take a look at the timeline for HTML5, like the first version of HTML5, the first working draft was created all the way back in 2007. This was created by the WHAT working group. So strangely, not by the W3C, and that's because, well, the WHAT working group came together to do it independently from the W3C. And then, you know, it went through a whole process of continuous evolution until we got like a candidate recommendation in 2012 and a full recommendation in 2014. You'll also note that this timeline shows that the original HTML5 spec got retired already a long time ago, like 7 years ago or so. So should we actually call it still HTML5? Well, actually not really, because nowadays there's just an ever-evolving document called the Leuven standard that the W3C and the WHAT working group agreed upon. But in general, the bottom line is when people say HTML5, they just mean the continuous, ever-evolving HTML spec. With that out of the way, you might be surprised that the DOM extension actually didn't support the HTML5 spec until very, very recently. If you want to know why, in PHP 4, the DOM extension actually started out as something called the DOM XML. And, well, it kind of already gives a bit of a hint. The XML part emphasizes that this was back in the day when everyone thought that XML was going to be the future of every data format, which didn't really happen. But back then, we already had like an API to query, validate, manipulate, parse XML documents and do all sorts of stuff with it. But it originally did not come with HTML support. And in the backend, this is powered by an XML library called libxml. In PHP 5, this got extended in scope, and now we have HTML support, but the HTML support comes from the libxml library, which is kind of strange because, you know, libxml, not libhtml. But that's only limited to HTML4, and it was intended as more of a convenient feature. So, yeah, we didn't have HTML5 support because the underlying technology that it was built upon didn't support and doesn't support HTML5. But why do we even need HTML5 support? There's a whole class of issues called parser differences or partial differentials. That's simply because the HTML4 and HTML5 spec are not compatible with each other. HTML5 actually broke backwards compatibility in many, many ways. And this leads to different interpretations between what PHP sees and what your browser sees. So there's like a clash between the two in how the document is parsed and how the operations work on them. And this can cause all sorts of issues like content corruption, security issues, and there's also just behavior differences. So to make it a bit more concrete, the first thing you may have noticed if you ever used the DOM API is that it cannot handle semantic tags. So in HTML5, we have these tags like main, article, nav, section, and so on. And a lot of web pages use these tags. However, this didn't exist in HTML4. So when you try to load like any reasonably modern web page, you just get a whole bunch of warnings. And you may think, okay, warnings aren't that bad. But actually, this influences the way that the document is parsed. Another example, and we gradually start to come to the more problematic cases. Another example is how text is parsed in HTML4 versus HTML5. So this is some code. So I basically load a snippet of HTML inside of the DOM, and then I just print out what it read. Just a scripting tag with a variable called foo, and just contains like some HTML snippet. And embedding HTML inside of JavaScript is relatively common these days. But if you actually look at what comes out of it, you'll see that something's missing here. The closing tag for the P is missing, and that's because in HTML4, the parser isn't really aware of how a scripting tag works. And so when it's, well, very strangely, when it reads the open P tag, it doesn't do anything. But when it reads the closing tag, it thinks that it should correspond to the closing scripting tag. And then it sees there was no open tag for the P, even though there is one. It gets confused and it drops the closing tag. So it corrupts your JavaScript, which is, not very good. Named entities. So HTML5 comes with a whole bunch of extra named entities. One of these, I've just picked MLDR here, which is just like triple dots in the middle. This didn't exist in HTML4, so what happens is, due to the ambiguous ampersand rule, it interprets the ampersand as a literal ampersand, so you get the ampersand escaped, and you just get MLDR as text. And so the entity becomes corrupted, and you end up with a different document. But the best one is probably there's different rules in HTML5 of which elements you can nest and which you cannot. So, okay, a bit more code. But basically, I have an unordered list with a list item A, and then there's a nested list with just a single list item B. If you put this through the old DOM extension and you look at the output, you can see that it kind of changed the layout of the document. It moved the ordered list out of the unordered list. So in this case, it even moves elements. And this may give you some ideas of all sorts of things that can happen. There's also implications for security. So not only content corruption, but also security. And if you have paid attention and you know that this extension is used for validation and sanitization for HTML inputs, that's not really good. There's a whole class of security issues, and you can find many, many articles on this. There's many academic publications as well about parser differentials. Really interesting, you should look into it. And the first one is, okay, these are going to become more complicated and complicated, but I'll walk you through it. So in HTML4, you have the legacy doc type tag, which has a system ID and a public ID. And in this case, the system ID is just the word system, and public ID is like a string, which has a scripting tag in it. But the scripting tag is not actually a scripting tag, it's just a literal string. In the next line, I just print out what the DOM extension read, and then we dump out how many scripting tags it found in the document. So yeah, this is what it outputs. Funnily enough, VS Code highlights it as if it's actually a literal string in the doc type. And for HTML4 it is, but not for HTML5. If you check how many scripting tags there are in this document, you'll see that it reports 0. So you might think, well, there's no XSS. But in reality, if you execute this code in Firefox, you get the alert box from the scripting tag, because there's only one valid doc type in HTML5, and that's just doc type HTML. So when it read the greater than sign, it just closed the doc type, and the scripting tag actually becomes part of the document. But the sanitizer or the DOM didn't actually see this. Comments are also fun. The way comments work differs between HTML4 and HTML5. So I kind of have a malformed starting comment here, which is like a mesh between an open and a closing comment. And then I have a scripting tag that follows it. And maybe you can already see where this is going. But basically, again, very funnily enough, VS Code renders this as a full comment, even though, well, so this is the output from the scripting tag dump. But if you execute this in Firefox, you get the alert box because comments work differently in HTML5, and so the mesh between the open and closing comment doesn't actually close the comment in HTML5, even though it did in HTML. Sorry, it closed the comment in HTML5, but didn't close it in HTML4. There's many more examples, like micro XSS, where you can abuse the no-script tag, for example, because it changes the way some elements or attributes are parsed. Void elements differ, like some tags are implicitly void, and the self-closing tags from HTML4 or XHTML no longer exist in HTML5. And there's issues with foreign content. If you don't know what foreign content is, this is just when you embed SVGs or ModML or these kind of XML-based languages inside of your HTML, then the parser has to switch states. So yeah, lots of issues there too. I've put some sources on this slide as well. For example, GitHub had a parser differential issue last month, in which you could bypass some authentication. I'll make sure that these are available, these slides are available later. Because of all of this, in the documentation, we had to add a note after many security reports that emphasizes that the old DOM stuff used an HTML4 parser, and that the way that HTML5 works is different, so that these functionalities are not suitable for sanitization, even though people do this. So because of all these issues, like even 10 years ago, this was somewhat known to some extent, and people have built user-land solutions. The most known is Mastermind's HTML5. Maybe some of you have used it, maybe not. But it also is the basis of like popular sanitizers like Typo3 sanitizer and the Symfony sanitizer. Yeah, in general, many packages use this technology as the underlying parser. However, what you should be aware of is that the user-land parsers are inherently limited by what the DOM extension can do. And so, besides that, you also have the issue that the Masterminds project is already over 10 years old, and it uses like a spec from 2015, 2016. So it's a bit behind of what we currently have. And also very interestingly, it has known parser differentials. So let's take a bit of a deeper dive into it. I'm going to give you a quick tutorial on how to hack Sanitizer 101. Basically, I got a CVE for this, and very interestingly, someone else at around the same time discovered the same issue independently of me. So it shows that people actually look for this. But this is an issue in how the Masterminds user-land parser works. So if you just take a look at the README, it has a section known issues or known bugs, which is always very nice if you start a security analysis by just reading that section. Even more interestingly is that they say that they designed some things against the spec knowingly. There's a very, very interesting snippet there about processor instructions, that HTML5 doesn't support processor instructions, but that they do. I don't know if, does anyone know what a processor instruction is? Only one person? Okay. Actually, all of you do know what a processor instruction is. A processor instruction looks like this, where you have like less than question mark, you have a specific app target, that's some data. And the idea is that some external program can read this specific app target if it's meant for them, and then it does something with the data. And if this looks familiar, then you know it is familiar, because the most popular app target is PHP. So yes, the PHP tag is actually a processor instruction. And I think the reason, so this is a bit of speculation, but I think the reason that Mastermind supports processor instructions is that you can then read PHP documents using that parser. But yeah, now the question is, how can we exploit this? First, we need to know what happens if we use like a processor instruction with Masterminds. So this is how you use a Masterminds API. It's very similar to how you use the old DOM API, where you have like a load HTML and save HTML. And in this HTML, I just have a p tag, and then I have a processor instruction for the target X, and the data is just empty. In Masterminds, that's just round trips. So there's only like a p tag and a processor instruction in the document, so that's fine. But a browser creates something like this, which looks like a bit weird, but the HTML5 spec says to fall back to a special type of comments. So if we focus our attention on the processor instruction, we may ask ourselves, can we do something funny with this? What happens if we add a closing comment tag in between? So for the Masterminds, this is just round trips in the DOM. But for our browser, the closing comment tag now actually becomes the closing comment tag of the transformed processor instruction. So we end up with a very weird comment, followed by the literal text question mark greater than. So now we have a way to inject something in the processor instruction that is not injected in the document for Masterminds, but is injected in the browser. So if you now add a scripting tag, for the Masterminds, all of the comment and scripting tag stuff is just part of the application target for inside of the processor instruction. So the scripting tag does not participate in the document tree, but for our browser, because of the trick I showed earlier, the closing comment tag closed this monstrosity processor instruction comment tag hybrid, and the scripting tag actually becomes part of the document. So now we have actually a way to do XSS without the Masterminds parser actually knowing about it. And this led to a CVE in 2023, where you could just do arbitrary XSS injections very easily using that userland parser. In particular, this was supported to Typo 3 CMS, which has like a sanitizer, and which has some, for example, rich text editor common UIs, which are common for like blogs, etc. And it was very trivial to just inject some XSS there. For Symfony, not very interesting exploit there. You could just inject some tags, but those were allowed anyway. You could just do it in a very bizarre way. But that's also been fixed in the meantime. So now you understand why we need proper HTML support native to PHP. So how did we solve it? Well, first we need to go over the design goals. So basically, it has to be a drop-in replacement of the old DOM API so that you can just swap to the new API without any issues. It should be mostly backwards compatible. So user code should be able to easily swap to the new parser without much issues. The first-party extensions in PHP, like the simple XML and the XSL stuff, should just transparently work with the new DOM stuff, because they interop nicely with each other. And third-party extensions, like the ones in Packle or in Py, should just work. Clean API, I won't go over the horrible mess that is the old DOM API itself, but we really needed a cleaner API, especially with respect to encoding handling, which the old DOM API defaulted to, the ISO Latin one or whatever it's called instead of the UTF-8, which is very fun. And we wanted to use existing HTML parser because the HTML spec is a bloody mess of hundreds of pages with a lot of space dedicated to error recovery, which is a pain in the ass. But basically, the reason we can just swap the parser is because underlying the DOM extension, as I've talked about earlier, it's just like libxml objects, and the PHP classes are just like proxies or views over those objects, and they manipulate these objects in various ways, etc. So, for example, the DOM element class just proxies the PHP calls into libxml, and same thing for other classes like DOM text, etc. So it's all very transparent as long as we have a document tree in libxml. The HTML5 parser that we chose is Lexbor because it already had bindings for Python, D, Crystal, etc. It was robust, well tested, well maintained, tested on millions of pages. So we knew that it was a good fit. I once got a question, why don't you just use the Firefox DOM? And the answer is that everything is tightly coupled into our browser. So we couldn't pull that out of Firefox and integrate it into PHP. So another nice benefit of Lexbor is that it's standalone. And then, Lexbor parser gives you a Lexbor tree, Lexbor document tree. You just have to convert it to a libxml document tree, and then, it doesn't matter where the tree comes from, because in the end, it's just objects with the same interface. And API-wise for userland, the existing classes like DOM document, DOM node, with its subclasses like DOM element, DOM text, etc. And they just map to like a new DOM namespace, DOM is a new global namespace, which has some classes in it, like document, which has now split subclasses between HTML document and XML document. But the mapping is straightforward. DOM element maps to element in the DOM namespace, and so on. I'll just emphasize that the reason we had to make this split is because not only is some of the behavior and some of the parsing wrong, but also sometimes the property types and the argument types were wrong in the old DOM stuff. So, yeah, a little bit of a mess. Yeah, and just to emphasize that it's all just drop-in replacements. So basically, the only major difference is that you now use named constructors instead of load HTML, etc. But all the libxml options, libxml error handling APIs are all either emulated or like hooked into, so that all works transparently. So you can just, in theory, change the types of your classes that you use if you want to switch to the new API. Also, yeah, this all just transparently works with simple XML and XSL. Spec compliance. So I've already talked about the Watch working group and how they developed the HTML spec. They also developed the DOM spec of how browsers should implement the DOM and how other vendors should implement the DOM. And unfortunately, PHP didn't properly implement this in the old API. So another major task for PHP 8.4 was fixing all of that in the new API. I'll make it a bit more specific. But first, you could ask the question, why don't we just change the behavior of the old DOM classes? And we tried, but there's problems with backwards compatibility. And the reason is that if a behavior is so long in your system, like this behavior has been in the system for since 2004, that's like 21 years. If something has been that long wrong, it actually becomes right. It's a feature, not a bug, or more specifically, Hiram's law, which says that every part of the API that the user can observe will actually be dependent on, and this is something we keep running into when we try to fix things in PHP, that there's always people who rely on weird edge cases, and it makes fixing issues very complicated. So one thing I like to joke about is that we can't fix crash bugs because, you know, people rely on crash bugs to quickly shut down a request. So, but yeah, all of this crap is fixed in the DOM namespace in PHP 8.4. So hopefully no more problems. And just for funsies, some fun examples. This is mostly XML based because I could give an entire other talk about how XML sucks, but yeah, probably most of you know that. But basically, this is just some code that parses some XML. Like it's this container element, and it has an align attribute. And then we change the align attribute from center to hello world, and finally it does something right. The value just round trips. But what happens if we start using a numeric entity? So this is the numeric entity for the ASCII number 1. And then we can see that it actually decodes the entity. It substitutes its value. So this sounds very XXE-like, if you know what it is. If you don't know what that is, just another horrible mess from XML. But basically, the problem is, once you start replacing like these special escape codes with the actual code, you're unescaping HTML, which is a security risk. So how do you solve this if you're stuck using the old API? Use a DOM text clause or avoid or escape the text. So then you actually have to escape twice. Fun fact, turns out that Drupal CMS actually had a bug about the double escaping like years ago. Or my favorite solution, just avoid this. Prefixes, so XML has a namespace feature in which you can, you know, to not have clashes between tag names, you may want to have separate namespaces between the tags, and they're separated by a URI and a prefix sometimes. So in the first case, we don't have any namespace. In the second case, it's in the empty namespace, but without a prefix. And in the last case, it's in the UNX namespace with prefix X. And then if you actually read the prefixes, then it's empty string X. You may be wondering, well, isn't this right? And the answer is, well, there's no prefixes in the first two cases, so it actually should have said null. Does this cause problems? Yes, because people who are used to JavaScript expect null to come back, but now they get the wrong data back. And if you try to fix this, as I said, people actually rely on this being the empty string, so yeah, troubles. But again, this is fixed in the new classes. Default namespace, so basically I create some SVG element here, and I add a path element as a child, and then you get something like this. So this looks reasonable, except for the fact that the path element just had create element. It's not create element in a particular namespace. If you dump out the namespace of the path, you get the null namespace back, which is right because it was not created in a specific namespace. But if you know something about XML, you know that namespaces are actually inherited. So if you just look at the serialization, the path namespace is actually in the SVG namespace. So when you reload this XML, the namespace of the path element changes. Which, yeah, I have no words for this, but horrible. Definitely did not cause issues ever. And again, fixing this, big issue. Yeah, this is actually what the expected result is if you ran that code. The XML namespace should have actually been reset in the path, and then it all works properly. And this is actually what browsers do if you execute the equivalent code. So yeah, if you're stuck on the old API, don't mix these namespace aware and non-namespace aware APIs. But finally, for some fun stuff, we also have some new DOM features in 8.4. Like besides the fact that we have HTML5 and spec compliance, we also have some cool stuff like the inner HTML attribute or property, class list, etc., and also native CSS selector support. So no more pain with export. So inner HTML, yeah, I mean, if you've used JavaScript, you know what this does, right? It just does what you expect it to do for once. You have like a p tag here, and you append something to the body, and you get like the concatenation back if you save it. Class list gives you a way to. This also exists in browsers, by the way, but this is a bit lesser known, I feel like. But this gives an easy way to deal with token lists, or in general with the class attribute in browsers, in which you can just manipulate it like if it were a set, and it properly normalizes white space, etc. And you don't have to worry about double tokens inside of the class list. It also, I also demonstrate that by first toggling away dark mode, and since centered is already in the class list, it's not added twice, etc. So it's all very convenient. Native CSS selector support. So this is one of the more bigger features, but basically, in this case, I load a document with like a main tag and 2 articles, and I use query selector to get, the last one, which is a B in this case. This is only supported since PHP 8.4 because previously you had to rely on fun export stuff. So you could do it, but it was a pain in the ass to do it because, export is not fun. You have some user-land solutions that do the translation for you, but those are slower than actually having the native query selector support. Also, query selector all matches and closed, etc. is all supported all natively. So that's all I wanted to say, really. Thank you for your attention, and if you have any questions, I'm happy to answer them.
Thank you, first of all. Second of all, just in case you don't have enough CVE, and you have mentioned that it's not feasible to include Firefox itself inside PHP, but are there any plans to include some kind of JavaScript processing engine like V8 or something like this inside PHP, make it possible as an extension?
It would be possible to implement something like that as an extension, and I think it would not actually be that hard because the V8 API is quite embeddable. I haven't seen anyone talk about implementing something like that in PHP. I do know of one integration of WebAssembly in PHP as an extension, but I haven't seen one for V8 yet. But it would be possible.
I'm pretty sure there is a V8 extension already. Like it might be a bit outdated, but I think there's a V8 extension somewhere on Pecco that you can probably like use and install. So yeah.
Also, technically, you don't actually need an extension if you use the FFI extension to interop with V8. So that might also be a pure user-land solution to deal with that.